Well, hello everybody, I hope you're all doing really well. We're back again this week with our HP Pavilion DAY11AMB6E0 motherboard. Now you may remember we got to a particular point with this last week where I couldn't get it fixed and I asked for you to post your comments and suggestions underneath. So what I'm going to do in this video is I'm going to go through each one of those comments and see if we can progress this repair. But just before going through the comments, I'm going to set out again the problem as we see it. So what I did last week was use my DC power supply to inject 19.5 volts at the DC input. When I connected this up, it started drawing 0.001 amps or 1 milliamp. This seems a little low. Most of the boards we've worked on here draw between 5 to 10 milliamps when they're in standby. So this seems to be indicative of fault. With the power supply still connected, I decided to use my multimeter to take some voltage measurements across the board. Starting at the DC input pin, I found that there was 19.5 volts at this DC input pin. We followed this along this track here the whole way down to this MOSFET. At the drain pins of this MOSFET we measured 19.5 volts, at the gate pin I measured 17.9 volts, and at the source pins I measured 19.45 volts. Now this value for the gate pin seems a little unusual, even though we are getting voltage on the source pins. So what I did after last week's video was I connected a jumper wire from drain to source, and when I did that it didn't make any difference. The laptop still wouldn't power on, so I'm not sure that there is any issue with this MOSFET. So after MOSFET 1, the path that our 19.45 takes is down onto the drain pins of this N-channel MOSFET right here. I measured the gate pin of this MOSFET. It measured 25.3 volts on the gate, which is good, and I also measured 19.45 volts on the source pin. We then followed it down to the current sense resistor, which is this one right here, and I also measured 19.45 volts after this current sense resistor. After verifying that we had 19.45 volts at the current sense resistor, I then wanted to check and see if we had our LDO voltages, our 3.3 and our 5 volts always on power. So I followed my 19.45 volts right across the board, and if we follow it across the board, you will see that it comes to these two little ICs right here, PU11 and PU12. At PU11 we measured 19.45 volts on pin 8, which is the input, and we measured 3.3 volts on pin 5, which is the LDO output. There was 0 volts on the switched output, but this only comes online, as far as I'm aware, when the laptop is powered on. At PU12 we measured 19.45 volts on the input. We measured 5.16 on the LDO output, pin 7. This is our always on 5 volts. And on the switched output, I measured 0 volts. Again, I think this is only meant to be switched on when the laptop is on. Next, we went to the Super I/O and we confirmed at VSTBY, which is the voltage input for the Super I/O. We measured 3.3 volts there on those pins, so that's good. We have a good input voltage to the Super I/O. We then worked out where the power button switch comes in, which is this NBSW01 hash. We measured 3.29 volts on this, and when we grounded this to simulate the power button being pressed, the current draw went from 1 milliamp up to 4 milliamps, but then almost immediately back down to 1 milliamp again. The last measurement I took at the Super I/O was at pin 119, the RSM reset pin, and this measured 0 volts. I checked the bias pin, pin 8, for input voltage, and I was measuring 0 volts at pin 8. So that's where we left it last week. So let's go to your comments and see what you guys suggested. Okay, I've grabbed all the comments from underneath the YouTube video and I've just dumped them in Microsoft Word. There's only 18, I think, by this morning, so I'll be able to go through all of them. First of all, Mina Jolie 5899 has given me two thumbs up. Thanks very much for your support. Keep on watching. I'm going to keep making videos. Lezo204 has written down, I know you got all the volts in the right places. Been there, but no fire up. What about injection of voltage with flare camera? Les, the laptop is only drawn 1 milliamp, so that's not going to be enough for anything to heat up. And I haven't identified any short of any component up to this point. So there would be no point in me injecting voltage, but if I do find a shorted component, we will certainly go straight to voltage injection. Next we have Ian BA123. The EC is usually powered by the 3 volts LDO, which we've established already, I think, for this motherboard. But the BIOS chip is usually powered by the 3 volts not always on ALW. 3 volt ALW and 5 volt ALW are usually present all of the time you're connected to the mains, even if the laptop is powered off. I'd be looking for those rails next. Okay, well, let's look at that. So that's a very good point that you've made, Ian. So if we take a look at PU11, you will see that we have established it's getting the correct input on pin 8. The LDO voltage is present, and the one that you have described as the ALW, that's described as just SW for switched output, I think here, is 0 volts. Similarly with the PU12, we have 19.45 volts coming in on pin 8. We have our 5 volts LDO on pin 7, which is measuring 5.16 volts. But this one here, which is called in the circuit diagram SW, again for switched output voltage, and you refer to as 5 volt ALW, that is 0 volts. So yourself and Carlos in the comment below seem to be in agreement that even though the laptop is just plugged in but not powered on, you guys reckon that we should have both the LDO and the higher current switched output, the ALW. I'm not sure about that, but all I can tell you is for this laptop we're getting 0 volts on both of these. But I'm going to come back to that afterwards. So let's look at the next comment. So the next comment is, sorry, it's just Carlos agreeing with this statement. So we might just check those 2 voltage rails and see if there's any issue with them. Next, Cellular TJ, I think that's how you pronounce it. I would check AC in signal, lid sensor signal, flash the BIOS, and then the SIO is bad. I will check those as well. I think the AC in signal you're referring to, I think that's on the Super IO, or is that the battery management IC? I'll check on both anyway. I think the lid sensor signal goes to the Super IO. The flash in the BIOS, I thought the BIOS, if there was an issue with the BIOS, that it would power on and start to draw current, but just not post on the screen. Because that's when we've had a corrupt BIOS before, that's been, you know, the symptom. Next, Don Trotter 1099, I think Fleur to check for something broken. The 0.001 draw is strange. Yeah, I've pointed that out earlier, Don. Usually it was somewhere between 5 and 15 milliamps when the laptop was powered off, but in sort of standby. Maybe backside of board has a dead cap. Well, I'm going to check for short in a minute. Thanks for the time you spent on drawing the diagrams, and thank you for taking the time to comment. For me, like amateur, very simple and professionally explained. Thank you very much for that, and thank you for your comment also. Next, JFix. I think a good check is a probe around and check each coil for resistance to ground. Yeah, if you've watched any of my other videos, JFix, you know that's one of the things that I do. We will certainly do that next. So in accordance with JFix's comment, we're going to check the diode mode readings of all of the coils on the secondary rails. The most appropriate place to start, I guess, is at PU11 and PU12. So PU11 has its LDO output, which we're measuring and is correct. It also has a higher current switched output on pin 10, which I'm measuring as 0 volts, but most people seem to think that this should be measuring 3.3 volts. So what could stop it from switching on? A short could certainly do that. Similarly with PU12, we're measuring 5.16 on the LDO always on power, but we're measuring 0 volts on the higher current switched output, which people think should be on as well. So in diode mode, I took measurements for all of the coils with the power off, of course, and this is what I measured. So for coil PU12, which is on the switched output, the 5 volt output from PU12, I measured 0.295. So that is not indicating a short. Similarly, on PU11, I measured 0.386 with the power off in diode mode. So that is not indicative of a short either. Going around the rest of the coils on the board, on PL22, I measured 0.125 volts. So that's okay. Again, these will measure lower the closer you get to the processor. So it's measuring 0.080 volts on this, so no short there either. On this, which I think is the inductor on the battery charging circuit, 0.209. And down at the bottom down here, Who left that multimeter there? PL16, I'm measuring 0.194. So there's nothing about those measurements that indicates that there is a short. Back to the comments. Carlos Garcia. Carlos, how are you? Page 36 schematic. PU11 is not equal to PU12. Don't ask me how I know, but study every pin. All the best. I was just a bit curious about this one, Carlos. I think I understand what you mean. PU11, the LDO output is on pin 5. And a PU12, the LDO output is pin 7. Even though it appears to be exactly the same IC. You might just confirm for me in the comments that I've understood you correctly there. Next comment. I think you should just mark every 16 pin and use it like a clock to point to the pin you need. I think this is in reference to my comment about how long it took me to draw out the 128 pins. But I've actually found a way of doing this quite easily, so I don't think that's going to be an issue. And what seems to be the case is, because I'm scanning at the same resolution, if I draw out the pins for one motherboard, I can simply drag and drop those as a new layer onto the image of the one that I scan for the next week. But I'm sure people aren't interested in that. Next, Greg, follow the power sequence from the circuit diagram if you have it. Greg, there doesn't seem to be a full power sequence on this one. But I'm going to try and find a different circuit diagram that has one, and we'll follow it from that. Cool video, thanks. Thank you very much for your comment. I've never seen this kind of presentation. You're amazing and unique. People are going to think that I posted this comment myself, that I set up a separate account, but honestly I didn't. Thanks very much for your comment. I just try and produce them in a little bit different, and I try them to make them clearer than other channels. I wouldn't have set up a channel, to be honest, if I didn't think I was doing something different, because there are so many amazing channels out there doing this kind of thing. The only thing that I have is sort of unique, I guess, is the way I'm doing them in Photoshop, and I'm just seeing how far I can push that, just to make it as clear as possible. And like I said before, if people like it, they'll keep watching it and I'll keep making them. If people don't like it or think there are other channels that are better, then I'm happy enough with that. It's a meritocracy on YouTube, and I'm happy enough to play by those rules. Now, somebody did suggest checking around all the USB ports and see if they all looked okay or if there was possible damage. And while doing that, it just brought me closer to looking at this IC right here. Now, I did see this earlier on, but there was a sticker, I think, on top of this board, and when it got pulled off, it left behind residue on quite a few of the ICs, and that's what I thought this was. But as I just scraped at it with my probe, it looked like there was a hole. So let's get a closer look at this. I zoomed in with my microscope and tried to clean it off with my toothbrush, and as you can see, it does look like there is a hole in the center of that IC U27. So where does U27 sit in the grand scheme of things? Well, if we look at that output from PU12 that we're measuring 0 volts, that on that output is this inductor right here, and then from there that feeds 5 volts into U27. If we look at U27, we can see it has 8 pins, 1, 2, 3, 4, 5, 6, 7, 8. As you can see, I've pulled up a partial schematic for this from our laptop's motherboard schematic. This is described as a power multiplexer. There's 5 volts on the 2 input pins, which I've marked here, and there is meant to be 5 volts on the output also, on 6, 7 and 8 when it's powered on. Now, as we saw already, this looks like it has a hole in it. So what I want to check is to see if there's a short on the input or a short on the output. Maybe it's just blown open, but let's just check for shorts on this first. So with my multimeter in diode mode this time, I place my red probe to ground and I place my black probe to V in pin number 1, and I find that it measures 0.29. So we've no short there. Next we want to measure the output pins, so 6, 7 and 8 are our outputs. So again, I place my red probe to ground, multimeter in diode mode, place my black probe to pin 8, and I find that it measures 0.302. So it's not shorted on the input or on the output, but the chip looks like it's blown. So with my hot air station and a bit of flux, I very clumsily removed that IC, as you can see, but I got it out anyway. So with that IC removed, I tried powering it on again, but unfortunately it's still the same result. However, I think we're probably getting closer to where the source of the problem is. If this IC is blown, which it appears it is, there may be something else in this area that is also faulty. And I am still curious as to whether this should have 5 volts at all times. I'm going to investigate that a little bit further, but unfortunately I've run out of time for this week, so there's going to have to be a part 3. But I enjoyed reading all your comments and including them in the troubleshooting procedure. If you like what I'm doing, please like and subscribe, and we'll be back with something else next week.